Assalamu alaikum wa rahmatullahi wa barakatuhu and good morning. We are in the last part of our Unit 2, Equilibrium of Rigid Bodies in 3 dimensions. So what is the need for studying the equilibrium of bodies? Why should we study equilibrium of rigid bodies?
To find the force.
I want answer from the back.
Force and unknown.
Force and moment. Why should we do that?
To find the reactions.
To find the unknown forces and moments. If we want to analyze a system which is affected by many forces and moments, we should know all the forces. We should know, if I say no, what do you mean by that? We should know the magnitude, direction and sense. Completely all the 3 parameters of the forces should be known in order to understand the effect of the forces. So for this, we are using this equilibrium of rigid bodies, equilibrium conditions. There are 2 equations of equilibrium, sigma F equals to 0 and sigma M equals to 0. Okay. And there are cases where these 2 equations are not applicable, or we can say not enough, not sufficient to find the unknowns. A system which cannot be completely understood by using the equilibrium equations. So these systems are called indeterminate systems. Indeterminate. They are indeterminate. They are not determinable. For example, we have a simply supported beam. A simply supported beam means it will have 2 supports, one at each end. Suppose there is another support at the middle. Okay, the support becomes redundant, unnecessary, not needed, extra. Okay, redundant. So in such a case, the system, knowing the unknown reactions of the system, the intermediate reaction will not be possible by having 2 equations. Okay, so these systems are called indeterminate systems, where the 2 equations of equilibrium is not sufficient to find out the unknowns. So for our syllabus, it is beyond the scope of our syllabus, so we are not going to touch the indeterminate system in engineering mechanics. Maybe you will be studying about this indeterminate system in your solid mechanics next year, next semester. Okay. So now we will continue with the 3-dimensional equilibrium conditions. Okay. Here we already started with equilibrium of body in 3 dimensions. A body in 3 dimensions means how many degrees of freedom it will have? 6 degrees of freedom. So what are the 6 degrees of freedom from the back side? Yeah. Last but row. Center man. Adam, the specs. Zakira. What are the 6 degrees of freedom? Be seated at it. Don't know. The next one, 6 degrees of freedom. The body in space will have 6 degrees of freedom, that is already told. From this side, from the back. எல்லாரும் கூட்டத்தோட லாஸ்ட் part one, yeah, tell me that.
Along X, along Y, along Z, along XY, along YZ, along ZX.
No. Okay, half is correct. Actually, this is 3 forces. Okay, you will have three translations. Along X, along Y, along Z, 3 translations. And next 3 is rotations. So you must say around X, around Y, around Z. Or about X, about Y, about Z. Okay, so 3 translations and 3 rotations. So you will have 6 degrees of freedom. When you arrest these motions, you will have support reaction. Generally, we can have to the maximum of 6 reactions. 3 forces, reactive forces and 3 moments. So we will say that there are 6 equations of equilibrium. Sigma Fx equals 0, sigma Fy equals 0 and sigma Fz equals 0. The 3 forces because of no motion in the xy, no translation. If there is no translation, So the sigma f will be equal to 0. Sigma fx will be equal to 0, fy equal to 0, fz will be 0. Similarly, if no rotation, you will have sigma m equal to 0. Sigma mx, sigma my, sigma mz equal to 0. Okay. So the three translations will produce three equilibrium equations: sigma fx, sigma fy, sigma fz equal to 0. Three rotation will produce three moment equations: sigma mx, sigma my, sigma mz equal to 0. So we have to apply this for our problems to find out the unknowns. So we already started with the different types of reactions. How many reactions we will have? Okay, the first case, we have a frictionless surface, frictionless smooth surface. If it is smooth surface, only one reaction. If it is like this, a wheel on roller, it can translate in y direction. Okay, y direction only. It cannot translate in x direction, it cannot translate in z direction. So it will have two forces. Third case, you have a ball and socket joint. The ball and socket joint can rotate in any direction, but it cannot move in any direction. So no movement, no translation. No translation means you will have three forces. Here only one translation is arrested. Okay, the translation in z direction is arrested. Smooth surface. So it can slide in x direction, it can slide in y direction. It cannot slide in z direction because of a support at the bottom. Because of a support at the bottom. So you have only one force. Here you have two forces because two movements are arrested. You have three reactive forces because the three movements are arrested. A cable will have one reaction. Okay, cable connected member. This is an universal joint. It can rotate. It can rotate in around z. It can rotate around x also, but it cannot rotate around x, around y. So we will have one moment, and it cannot translate in any direction. So we will have three reactive forces. These things, if it is a fixed support, no movement at all, no translation, no rotation. So another we will have six reactive forces and moments. So these things we already covered. We have started with this problem. Okay. So in this problem we have a bent pipe. This bent pipe has got a ball and socket support at point A. So ball and socket means it will allow rotation in all directions, but it cannot allow translation in any direction. So three reactive forces you will have. And there is a bearing at point B. So bearing allows rotation about Y. Okay. But there is only two forces you will have. It cannot allow. It can allow it to move in y direction. It can translate in y direction. It cannot translate in x direction. It cannot translate in z direction. So two supportive reactions you will have, reactive forces, and point C only one support. Okay. Only one support is there. It cannot move in your z direction. So only one reactive force. So if you draw first, in order to find out the unknowns, first we have to draw the free body diagram of the bent tube. So the free body diagram will be like this. You will have three forces, three reactive forces at ball and socket joint. At bearing, it has two reactions, no movement in x direction, no movement in z direction, so two reactions. And at point C, one reactive force. So after showing all the reactive forces, now we have to find out the unknown forces by using our equilibrium equation, sigma fx, sigma fy, and sigma fz equals to 0. Here if you see, there is only one ay, only one reactive force in total. If you consider all the forces given, only one force is given now. This is applied force. 900 Newton is the applied force, given force. Okay. Whereas the other forces are reactive forces due to the support, reactive forces. So consider all the forces now. You have only one force exists in y direction. There is no other force exists in y direction. So if you write sigma fy equal to 0, that equation, since there is no other force in y direction, your ay will be equal to 0. In order to make the system equilibrium, your sigma Fy should be equal to 0. So Ay will be automatically equivalent to 0. Now we have to find out the other forces. Okay. So to find the other forces, we use moment equation. If you remember in our 2D problems, first we use sigma Fx equation if there is a x reaction. If there is a reaction in x direction, we have used sigma Fx equation and we will find out the x reaction. After that, we will use moment equations and if needed, force equation also. Sigma Ma equals 0, sigma Mb equals 0, then sigma Fy also equals 0. Like that we use. So in the same conditions applied here, since there is only one Ay, we first use sigma Fy equals 0, that moment, that force equation, equilibrium equation, and we found that Ay is equal to 0 since there is no other force. Now in order to find the other forces, we want to find out Fc, we want to find out Tz, Bx, etc. So Fc can be determined by summing up the moment about y-axis. Now we take moment of all the forces about y-axis. So Fc moment is force times its perpendicular distance. Fc times its perpendicular distance is 0.6 meters. And this 900 is there, that is also acting in either direction. It will have moment about y-axis 900 times 0.4. Whereas the other forces Bx, Bz, Ay, Ax, Az, they are all passing through y. So their perpendicular distance from y is 0. Their perpendicular distance from y is 0. You are taking moment about y-axis. So you must measure the perpendicular distance from y-axis. Only two forces, they are away from y-axis. Fc is 0.6 meters away, 900 is 0.4 meters away. Only two forces are away from y-axis. So if you write that moment equation, sigma My equals 0, Fc times 0.6 minus 900 times 0.4, because we consider the anti-clockwise as positive and clockwise as negative. So if you say Fc is acting in this direction, its moment, this is moment arm. Okay, so it makes rotation in anti-clockwise direction, positive. Whereas the other force, your 900 Newton is acting like this, its moment arm is here, so it will make a rotation in clockwise direction, negative. Okay, so Fc, its moment is positive, whereas 900's moment will be negative. So we finally got Fc as 600 Newton. Okay, now we can find out similarly, how will you find out Bx and By? What direction we can take moment? Say we want to find out Bx now. How will you find out Bx? Around?
Moment.
X or Z?
The summation we can take.
Along X.
Now in order to find Bz, we can take moment about x-axis. Okay, for finding Bz. Bz is here. Bz is here. So to find the moment of Bz, we can take moment about x-axis. To find the moment of Bx, you can take x-axis or z-axis also. So I find first Bz by taking moment about x-axis. So three forces are away from x-axis. 900 is away from x-axis. Okay. And Fc, Bz. So we got a negative sign that indicates that Bz is what we assumed is wrong. As I told you, remember, we just assume the reactions as upward or downward. If your results are positive, your assumption is correct. If your results are negative, the actual value is opposite to what you assume. Actual sense is opposite to what you assume. Okay. So actually we have assumed Bz as acting upwards. Here we got a negative sign, minus 450 Newton by taking moment about x-axis. So if you take moment about x-axis, this Bz is minus 450 Newton. So we say that it is acting downwards. It is not acting upwards as we have assumed. Actually, it is acting downwards. So Bx can be found by summing up all the moment about Z axis. Similarly, Ax can be found by considering sigma fx. That is already 0. There is no force in Engg direction. Since Bx is 0, Ax will also be 0. Az can be found by considering sigma fz. Az, so we consider forces acting in Z direction, and Az is found as 750 Newton. Okay, so first we take sigma fx, then taking moment about x, moment about z, then using sigma fx and sigma fz equation, we found the other unknowns. You can use moment equations also instead of force equation, but force equation is simpler. We need not multiply it by the perpendicular distance, so it will be simpler. That is why we prefer force equation if it is possible to find by force equation. So we got all the unknowns. So if you have any doubt, you can ask. Let's see on the taking moment about x axis, y axis. Take moment about y. I will go to previous lecture. Problem. From the answer. This is the solution. Summation of all. Summation of all the x array. E is not We have 6 equations. So first moment equation use பண்ண பார்க்கணும். Moment equation use பண்ணி solve பண்ண முடிஞ்சது solve பண்ணனும். அதுக்கு அப்புறம் fourth equation. This is another similar problem, but here we cannot use scalar method. So far in the first problem we have used scalar method. We have just used force and its perpendicular distance. force and its perpendicular distance. So that is a scalar method of finding the moment. Okay, we have used sigma m equals to 0. For that we are finding the moment. For finding the moment we have used scalar approach. In this problem, the rod is in the space and it is not at all parallel or perpendicular to any of the axes. The rod is inclined to the axis, inclined to x, y and z axis. Okay, only the cables are parallel to your x and y axis. So you have a rod. One end of the rod is in the ball and socket joint. Okay, the other end is kept in position by two cables. BD and PE are two cables. Okay. At the point C, you are applying some force, 200 Newton. At point C, some force, downward force is applied. So you have to find out the reactions at the ball and socket joint and the tensions in the cable BE and BD. You have to find out the tensions at the cables and reactions. So if you draw the free body diagram of this rod, that is enough. We have to draw the free body diagram of this rod, which represents reactions at point A. 3 reactions. It is a ball and socket joint. Similar to our previous problem, if you have a ball and socket joint, it is like holding something in our hand. Okay. So it can rotate in all the directions, but it cannot slide in X, Y and Z directions. A ball is kept in a socket, like our knee joint. Okay. So a ball is kept in a socket which can rotate about all the 3 axes. Rotate about all the 3 axes, but it cannot translate, it cannot go to and fro in X, Y and Z axis. So the ball and socket joint at point A will have 3 reactions, X, Y and Z. AX, AY, AZ. Whereas at point B you will have 2 tensions. Point B, there is a tension by the cable BD and there is a tension by cable BE. Parallel to Y and X axis respectively. 2 tensions. Okay. And also there is a middle applied force. So if you draw the free body diagram, the first step, this is the free body diagram. You have 3 reactions at point A due to ball and socket joint. 3 reactions. Then 2 tensions, BD and tension at cable BD and PE. Okay. That is denoted as TD and TE. Then you have an applied load at point C. So these are the force system you have. Okay. So how to proceed for finding out? So in order to find the moment of the force C, okay, moment at the force C, moment at the force acting at point C, you will use the cross product approach. Okay. So for that you must know the position vector for line AC. Position vector for line AC. Then you can. So first we represent force and all the forces in Cartesian form. A force acting at point A. There are 3 forces. You can sum up it as a resultant force. Okay. Resultant force acting at point A as AXI plus AYJ plus AXP. 3 forces similar to the problem which we did in 2D. If you remember that lever problem. Okay. In that bell crank lever was there. The bell crank lever will have 2 forces. It is a hinge joint. It was a hinge joint. The hinge joint cannot move in X or Y direction. So the 2 support reactions we replace it with a single resultant. In similar manner, the 3 forces AX, AY, AZ, if you represent as a single force in a Cartesian form, it is written like this. Force acting at point A as in Cartesian form like this. Then TE is the force acting parallel to your x-axis. So you will have only TEI, unit vector I, x-axis only. Okay, TD is tension existing parallel to y-axis, so TDJ. And this force acting at point C is a vertically downward force parallel to z-axis. So 200 K. Okay, so we have represented all the forces in the Cartesian form. So in order to find the moment, if you just take the position vector R cross F, you can find out the moment. So first we use force equation. sigma F equals to 0. Sum up all the forces. You split into I, J, K components. So you got three equations. Ax plus T equals to 0, Ay plus Td equals 0, Az minus 200 equals 0. By summing up all the I, J, K components of the forces, we got three equations. From the three equations, the last equation gives you directly the value of Az. Az is 200 Newton. Okay, Az is obtained as 200 Newton. After that, we take moment of the forces about A. So we take RC and this force 200 Newton, then RB times the two forces. RB times two forces. Using Varignon's theorem, we can apply the Varignon's theorem, T plus Td. So the cross product of the position vector RC and the force. Position vector RC and the force, position vector RP and the two forces. Okay, so we substitute. We know the positions for point C, so we can find out this position vectors. So arranging the I, J, K components, we got three equations for moment also. From the three equations, we can find out the unknowns. TD, TE and all the unknowns can be found. So we got generally six equations. Sigma F, three equations. Sigma M, three equations. So we already found A, Z. Other equations can be solved to find out the unknowns. So here the scalar method cannot be applied because the rod is in the space. We have to apply the cross product concept. So for that, we first convert all the forces into Cartesian form. Then use the cross product concept. Okay. The cross product of the position vectors from any point of application of the force to any point, the transmissibility is there. You need not be perpendicular. Okay, that is the advantage of using cross product. For finding the moment, if you use scalar approach, it should be a perpendicular distance. Okay, if you want to find the moment of C, moment of this force, moment at point C from the particular axis, it should be the perpendicular distance. You have to find out the perpendicular distance from the particular axis. But that is difficult because the rod is in space and its angle is not given. Angle will be difficult to find. So we use cross product approach to find the moment of the forces C and the tensions. Okay, moment of the forces at point C and moment due to the tension. We use the cross product approach. Cross product is any line connecting any two points between the two forces. So we want to find from here about A, we want to find moment of this force about A. Okay, so we can take any distance. It can be perpendicular, it can be parallel. So we assume it's parallel to the rod. So we just find the position vector along AC, position vector along AB, and we have found the moment by using the cross product approach, and we have split the equation into IJK components. We got three equations of moment and we have solved for the unknowns. That is the easiness of our Cartesian form and cross product approach. Need not find out the angle, which is difficult to find. Yes.
I just want to go to
X-ray